Hello everyone, my name is Gamanji and currently I'm a principal engineer at Apple. I have joined Apple 5 years ago, and as part of this role I am bringing Kubernetes and cloud native expertise to different teams and products within Apple. As well, I am part of the CNCF groups such as the TAB or the Technical Advisory Board and the TOC or the Technical Oversight Committee. Today, however, I would like to talk about the state of cloud native and more specifically the shift towards AI. And to do so, first of all, I would like to look at the industry 15 years ago, from the moment we started to have containers and actually started to adopt them in production at scale. Here we're going to look into how we got to a mature ecosystem with hundreds of tooling and thousands of community developers. Next, I'm going to focus on the AI shift. And this is something that is happening to us. For the last 4 years, we have a surge in AI-specific tooling and AI workloads. Here I would like to emphasize how the AI is shaping the open source world, but also the cloud native ecosystem. And finally, I would also like to focus on community sustainability. For any kind of talk that I deliver that is community focused, I also like to focus on the evolution of our community. Whilst the technology is the exciting part, we need to realize that none of it would be possible without a community around it. So let's start by looking at the industry 15 years ago, and more specifically how containers got globalized. Now, to run successfully a container, you require two main primitives, cgroups and namespaces. Cgroups pretty much imposes the limits on your process, such as the amount of CPU and memory it can consume. On the other side, namespaces imposes what the process can do, so it can interact with other processes, file mounts, networking interfaces, and so forth. However, these two primitives were available within the Linux kernel since 2008. Kubernetes was open sourced in 2015, so we had a 7-year gap between the container functionality being available and for it to be adopted at scale in production. So why exactly we had this gap? This is because the technology became the competitive edge for every single organization out there. As an organization, you had to solve 3 main challenges, which are focused on application complexity, fast deployments, and environment uniformity. Application complexity refers to the fact that organizations are operating in a microservice-oriented architecture. Now, while this simplifies the development of individual components, there are still challenges to be solved when it comes to scale and actually doing this in production efficiently. Next, we have fast deployments, and this is an imperative even nowadays. The faster you deploy, the more of a competitive edge you're going to have. And finally, we have environment uniformity. And this refers to the fact on how one can minimize the delta between the local environment and production. Now, all of these challenges were successfully solved by the introduction of containers. And more importantly, Docker at the time was a great tool to popularize the adoption of containers. And over time, there were multiple other initiatives to enable the execution of containers on different operating systems. And this is something that we have done at Apple as well. Last year during WWDC, we have introduced Container, which allows you to run Linux containers natively on macOS. It is optimized for Apple Silicon and also written in Swift. The best part about it, it's actually open source. So if you want to run Linux containers on your Mac, I definitely encourage you to check out the project. So at this stage, we have containers, we have them adopted in production. The next challenge the community needs to solve is scale. How do you manage thousands of containers at scale? This is where the container orchestrators enter the picture. And 10 years ago, this space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, CoreOS Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly, for its approach towards declarative configuration and automation. And this has been extraordinarily beneficial for it because over time, multiple tools were built around it to extend its functionalities, such as support for different networking, security systems, observability, and so forth. And this created what today we know as the cloud native landscape, which resides under the CNCF umbrella. Now, of course, as expected, the Kubernetes is leading in terms of the project development and velocity it has reached. Now, the velocity report is looking into all of the data related to commit frequency, contributor base, and also adopters. And based on the report last year, of course, Kubernetes is still leading within this space, and its velocity is sustained mainly because Kubernetes is also used by enterprise organizations. Later on, we will see that Kubernetes is further adopted for the AI workloads as well. So this is a continuity or a kind of continuity of relevance for this tool. Next, we have Backstage. And with an increased adoption of cloud-native architecture, it is only natural to focus on an improved developer experience. As such, projects or organizations are looking to implement their own IDPs or internal developer platforms. And very important here is that Backstage actually doubled this contributor community in the last 2 years. And finally, we have OpenTelemetry. And OpenTelemetry is the second largest project within CNCF, which also demonstrates the need for real-time telemetry when running systems at scale. A very important announcement here is that OpenTelemetry is currently graduated. It passed the graduation vote earlier this week, so I definitely would like to encourage, of course, the further development, but also to congratulate the maintainers and the community for reaching this wonderful milestone. Now, as you can see, we are starting to have different gravitational points of development within the ecosystem. However, in addition to these free tools, there are 200 other tools within the CNCF landscape, and these are dispersed across 3 different levels of maturity. We have sandbox, incubated, and graduated projects. Now, sandbox projects are niche greenfield ideas. They provide a solution for a small but well-defined problem space. Next, we have incubated projects. And here we'll already see more adoption in production, but more importantly, we see contributions from different organizations because we want to ensure that vendor neutrality in the project development. And finally, we have the graduated projects, and these projects are here to stay. They usually provide a solution within an established area within the ecosystem, and we also refer to them as the ones who cross the chasm, so pretty much move from early majority to early adopters. And currently within CNCF, we have 147 projects in Sandbox, 38 are incubated, and here we have 35, but actually 34, it should be 35, which are graduated. Now, if you look at the graph, I would like to draw your attention towards the faint gray line at the top of the graph. This represents our archive projects, and I don't think we talk sufficiently about archival. Sometimes it is natural for some of the projects not to reach that momentum in contributorship or adoptership, and I think it's very important for the maintainers to take the lessons learned and redirect their energies towards existing initiatives within the ecosystem, or by creating a new tool and open sourcing that. And within the TOC, they have conducted a lot of health assessment issues, some of them which resulted in archival. As such, we have 26 projects with this status at the moment. Now, this was a brief history of 10 years of cloud native. You can see how we reached a point where we have a mature and stable ecosystem. We have hundreds of tooling, but also we have a thriving community. However, even if it's a mature community and a mature ecosystem, it is equally important to keep remaining relevant, especially now with the surge of AI tooling and workloads. And this is something that I would like to focus on in the next section. To begin with, I would like to introduce the pillars of open source AI that were introduced actually by Jonathan here during KubeCon last year. Now, these pillars provide a structure on how we can categorize different AI tooling. The first one is going to focus on training. This is all about taking the data, raw data, and encapsulating this into an intelligent model. Next, we have the inferencing, and this is where we serve the model. So pretty much take it and fine-tune it to the data you have within your organization. And lastly, we have agents and applications, which is all about connecting that model to the outside world. It can be through the MCP, skills, chatbots, you name it. But more importantly here, you'll be able to see that all of these pillars are actually falling within their own communities. The training pillar is actually represented quite heavily by the PyTorch Foundation. They have 80% of market share for Hugging Face, so it's a mature community as well. Next, when you're looking into the inferencing and agents, these are emerging communities, meaning that we don't have an off-shelf solution that people will be able to use in production reliably. As such, the ecosystem is ever-changing. But if you look at inferencing, this is where CNCF has a real use case, especially for providing the orchestration layer for these kind of workloads. And when we look into the agents, this falls quite nicely into the mission and goals of the Agentic AI Foundation, which was introduced less than a year ago. So as you can see, we have 3 established, well, one of them is established and 2 of them emerging. Very important, we are at a point within the open source world where all of these communities need to partner and actually collaborate. But overall, I would like to take for you the following message. We have an open source side for AI, and I think this is extraordinarily important. We have all of this emerging tooling, which are great, but there is a lot of expertise we can offer from the open source side of things. such as maturity for security practices, observability, scope, identity, and so forth, but more importantly, on how to grow sustainable communities as well and apply governance on top of it. Now, looking within the cloud-native ecosystem, of course, we can see the shift towards AI here as well. Now, based on the CNCF annual report, 98% of their organizations have a cloud-native adoption implemented. That means that they use Kubernetes in some capacity. But 98%, this is a staggering amount of people, and we can see people are leading, or organizations are leading with Kubernetes as the first choice. Another characteristic here we have for Kubernetes is that it's boring. And I think this is an extraordinary achievement we could have actually set in the last 10 years. We have 10 years of capability development and also community momentum. It is only natural for Kubernetes to be stable, mature, and reliable in production. Next, we can see that 66% of these organizations are running GenAI workloads. Now, if we split this number, 23% are having a full adoption of the Kubernetes stack, whilst 43% have a partial adoption of the Kubernetes stack. Again, here we can see that teams are referring to Kubernetes as the first choice. They are leading with their infrastructure strategy here. But more importantly, what I would like to mention is that we are at a time very similar to DevOps, because Kubernetes can provide that unified layer to run normal workloads, but also compute intense workloads as well. So at the DevOps times, we had the Kubernetes being a tool that would bridge the gap between development teams and operational teams and infrastructure. And now Kubernetes is the tool that brings together the infrastructure team and the data science teams. However, running workloads on top of Kubernetes is not just about putting it in a container. There are multiple other requirements we need to consider when we run AI workloads specifically, such as how do we manage large model artifacts? It can be through either container registry or object storage. Do we have any strategies for training pipelines? Perhaps do we have any kind of canary rollouts and patterns that we'll be able to provide when training those ML models? So you can see that there is a lot of new functionalities we need to develop, but also solidify. And finally, we can see that 7% of these organizations are deploying this kind of workloads on a daily basis. A very important number here is that 47% are doing it occasionally. So we can see the disparity between the infrastructure readiness and the model deployment frequency. Now, what we also observe here is that teams prefer to consume rather than produce. So instead of actually training their own model from scratch, they would rather take the model and fine-tune it with their own data. So we can see here that inferencing has a very big use case on top of Kubernetes. And of course, we need to further optimize it when it comes to efficiency and scale. Now, if you'd be curious to see what end users are adopting within their production systems or something they are exploring at the moment or POCing, I encourage you to check the technology radars. Now, here you'll be able to see that they fall into the same categories as the open source pillars, such as inferencing, orchestration, and agents. Again, I would leave you to explore this. However, what's important here is that we have open source tools that people can adopt. And we have also tools that fall within the CNCF umbrella as well, such as K-Agent, of course, Kubeflow, and Q. And if you'd like to create your own infrastructure stack, I definitely encourage you to check out the curated cloud-native AI landscape that you'll be able to explore and choose tooling for inferencing, orchestration, data training, and so forth. And finally, as I mentioned, we have a lot of initiatives and optimization efforts that we need to conduct on top of Kubernetes to make sure that it is relevant for AI workloads. These are some of the initiatives I'm going to mention today. This is a snapshot in time of what we are working on as a community. I'm pretty sure this is going to change within the next half a year and a year, but I would like to showcase what we have at the moment. Briefly, we have DRA, or Dynamic Resource Allocation, which currently is GA as of Kubernetes 1.34. Now, DRA enables you to provide an abstraction layer for hardware and different accelerator types, so which is perfect for AI workloads. Next, we have a bunch of working groups. Now, working groups are supposed to be time-boxed efforts with their very clear exit criteria. So they either produce any kind of tooling, guidelines, white papers, you name it. So currently we have the AI Conformance Working Group, which is all about a list of requirements a Kubernetes platform would have to fulfill in order to run reliably AI workloads. So the main goal here is to make sure that if we have two platforms which are conformant, it will be easy to lift and shift one application from one platform to the other. Also, this aims to provide feature parity between different solutions. Next, we have the batch working group, and this is all about enhancement of batch support for workloads such as HPC, AIML, data analysis, and so forth. Next, we have serving, and this is all about creating an AI inferencing stack on top of Kubernetes. Very important, this working group is successfully archived as of February this year. And why I'm saying successful is because they actually accomplished all of the milestones they have set for themselves. So they have been working with the conformance group, and also they have branched out into a SIG. So the SIG inference performance is a natural continuation of this working group. And they, in terms of very specific capabilities, they worked on the Gateway API inference extension. Then we have the AI integration, which is all about seamless integration of machine learning control planes on top of Kubernetes. And of course, networking. We have the AI Gateway working group, which is all about extension of load balancing, gateway, and proxy functionalities to route traffic to AI workloads as well. And finally, we have the SIGs. As I mentioned, the inference performance is a new SIG that was created a few months ago, and it's all about creating a benchmarking tool to actually see the performance of your AI workloads. And we have the agent sandbox, which is all about running those isolated stateful workloads as well. Very, very quickly here, I know I'm on time, but I have another section that I would like to go through. What I would like to mention is that all of these initiatives, working groups, and SIGs, they are extraordinarily recent. And if you have a use case to run AI on top of Kubernetes, or if you'd like to get involved, now is the time. So I definitely encourage you to check out all of the information. It is publicly available. It is in GitHub, so pretty much you can join today if you want. And finally, whilst all of this technology is exciting, there is the AI wage, we are optimizing Kubernetes, we have innovation within our ecosystem. All of this is great, but we need to recognize that none of it would be possible without a community around it. As such, I would like to focus briefly on community sustainability as well. Now, from the beginning, the Kubernetes community operates on the principle that inclusive is better than exclusive. We create, build, and retain contributor communities through open governance, transparency, and a diligent code of conduct. This is what pushes innovation forward and invites everyone to contribute. Now, if you'd like to get involved with any of the CNCF projects, working groups, SIGs, initiatives, I encourage you to check contribute.cncf.io, where you'll be able to find more details. However, I cannot stress this enough. Contributions are not limited to code. There are multiple ways for you to be an active member of the community. It can be you providing feedback about using a tool in your production system. Perhaps you have a feature request, or would you like to report a bug? Or instead of focusing on one tool, you would like to focus on a broader domain, such as how you can navigate a domain within the ecosystem, or creating white papers. Now, all of this work is valuable and is led by our tags, or technical advisory groups. These are micro-communities that focus on a broader area within the ecosystem. And you'll be able to see that currently the tag view that we have is a result of the tag reboot that the TOC have kickstarted last year. Now, as part of the tag reboot, we have reduced the amount of tags from 8 to 5. And you'll be able to see that they are falling into the workloads that are actually currently happening within the ecosystem, such as operational resiliency, security and compliance, developer experience, and so forth. Another result of the tag reboot was the introduction of initiatives, which are very similar to working groups, meaning that they have a very specific timeline and also an artifact they'd like to deliver. And finally, we have the sub-projects, which are very similar to SIGs, meaning that they're going to be around for as long as we're going to have projects within the ecosystem. Because you can see they focus on very critical components within the projects, such as mentoring, contributor strategy, and project review. Now, I mentioned that within the TOC, last year, a very important workload was the tag reboot. This year, however, the TOC would like to focus on the graduation refresher. And this is all about all of the projects who have graduated maybe 5 or 6 years ago. We have to recognize that the criteria at that time and now is slightly different, and it's only natural because it evolved based on different requirements. Now, this initiative aims to help projects to retrofit some of these criteria, but more importantly for us to calibrate the criteria when it comes to maturity models. And finally, as a community, we need to remember that we are working on software that really changed entire sectors and industries and how they approach infrastructure build-out and management. At the same time, we need to still further diversify our governing board, technical and advisory committees. As such, I would like to encourage everyone here to continue building a diverse community. And this brings me to the perspective today. I know you're looking at me. It's the last one I brought. So, just as a recap, so far we talked about the container globalization and more importantly, how we reached an ecosystem that has hundreds of tooling with thousands of members. Next, we looked into the shift of the AI and how this is influencing the wider open source world, but also the cloud native layer too. And finally, we looked into the community sustainability and why it is important for us to scale at the same pace as technology evolution. And all of this has been possible because the cloud-native space has been in constant evolution. And even if it's a mature and stable ecosystem, we are able to see innovation within this space, which is amazing. But at the same time, we need to also value all of the expertise that we can offer to the cloud-native world, especially when it comes to building sustainable communities. Now, if you have any questions, I'm more than happy to answer them thereafter, or you can reach out to me on social media. This is Gamanji, and I look forward to seeing how you can shape the cloud-native ecosystem. Thank you, and enjoy the rest of the event.